Good job on the previous lesson. In the final lesson of this chapter, we'll talk about text data and regular expressions. Text data is one of the most common types of data types. Examples of it range from names, phone numbers, addresses, emails, and more. Common text data problems include handling inconsistencies, making sure text data is of a certain length, typos, and others. Let's take a look at the following example. Here's a data frame named phones containing the full name and phone numbers of individuals. Both are string columns. Notice the phone number column? We can see that there are phone number values that begin with 00 or plus. We also see that there is one entry where the phone number is 4 digits, which is non-existent. Furthermore, we can see that there are dashes across the phone number column. If we wanted to feed these phone numbers into an automated call system or create a report discussing the distribution of users by area code, we couldn't really do so without uniform phone numbers. Ideally, we'd want the phone number column to be as such, where all phone numbers are aligned to begin with 00, where any number below the 10-digit value is replaced with nan to represent a missing value, and where all dashes have been removed. Let's see how that's done. Let's first begin by replacing the plus sign with 00. To do this, we use the .strReplace method, which takes in two values, the string being replaced, which is in this case the plus sign, and the string to replace it with, which is in this case 00. We can see that the column has been updated. We use the same exact technique to remove the dashes by replacing the dash symbol with an empty string. Now, finally, we're going to replace all phone numbers below 10 digits to nan. We can do this by chaining the phone number column with the .str.len method, which returns the string length of each row in the column. We can then use the .lock method to index rows where digits is below 10 and replace the value of phone number with numpy's nan object, which is here imported as np. We can also write assert statements to test whether the phone number column has a specific length and whether it contains the symbols we removed. The first assert statement tests that the minimum length of the string in the phone number column found through str.len is bigger than or equal to 10. In the second assert statement, we use the str.contains method to test whether the phone number column contains a specific pattern. It returns a series of booleans that are true for matches and false for non-matches. We set the pattern plus bar pipe minus, where the bar pipe here is basically an OR statement, so we're trying to find matches for either symbols. We chain it with the any method, which returns true if any element in the output of our .str contains is true, and tests whether it returns false. But what about more complicated examples? How can we clean a phone number column that looks like this, for example, where phone numbers can contain a range of symbols from plus signs, dashes, parentheses, and maybe more? This is where regular expressions come in. Regular expressions give us the ability to search for any pattern in text data, like only digits, for example. They are like Control plus Find in your browser, but way more dynamic and robust. Let's take a look at this example. Here, we are attempting to only extract digits from the phone number column. To do this, we use the .str.replace method with the pattern we want to replace with an empty string. Notice the pattern fed into the method? This is essentially us telling pandas to replace anything that is not a digit with nothing. We won't get into the specifics of regular expressions and how to construct them, but they are immensely useful for difficult string cleaning tasks. So make sure to check out Datacamp's course library on regular expressions. Now that we know how to clean text data, let's get to practice.